Welcome to Lesson 4.1, Terminating and Repeating Decimals. Please make sure you have these notes in front of you. Any fraction can be expressed as a decimal by dividing the numerator by the denominator. Now, for the numerator and denominator, the numerator is the top part of a fraction and the denominator is the bottom part. If you're not quite sure how to write the division or how to do it, just remember that the numerator is inside the division box and the denominator will be on the outside. Now, after you divide the numerator by the denominator, there are two decimal forms that you're going to see. The first one is a repeating decimal. And the repeating decimal can be represented by using a bar or bar notation. For example, if I had 0.555 and it kept going, I could represent it as 0.5 and a bar over it. Now remember, the bar is only drawn over the part or the parts that repeat. If it does not repeat, you do not put the bar over it. Let's start with example number 1. So the numerator is 2, so that's going to be inside. The denominator is 3, that's going to be on the outside. So when you divide, it's going to look like this, the 2 on the inside, 3 on the outside. Now 3 can't go into 2, so we will need to put a decimal and a 0 and make sure to move it up top. 3 goes into 20 6 times. And as you can see, we're going to get a 2 again. If I drop the 0 down, I can see that there's a pattern going on. I can estimate that my answer is going to be a 6 on the other side, so I know it's going to be repeating. So your answer is going to be 0.6 or 0.6 with a bar over the 6. Example 2. Same thing here. I'm just going to think in over out. So I'm going to put the 1 on the inside, the 9 on the outside. I'm going to take that decimal. And because 9 can't go into 1, but it can go into 10. 9 goes into 10 one time. And as you can see, it's going to just keep repeating. So my answer is going to be 0.1 with a bar. The other type of decimal that you're going to see is a terminating decimal. And a terminating is kind of like the word terminate, which means to end, that it comes to an end, it doesn't repeat. So I'm going to start with example 3, 3 over 4. Same thing here. I'm trying to turn it into a decimal, so I'm going to use the in over out. So in my division bar, the 3 is going to go on the inside, the 4 is going to go on the outside. Now 4 can't go into 3, but it can go into 30, so I move my decimal and the 0. 4 goes into 37 times. I have 28. I subtract that, I'm going to get a 2. Take a 0, drop it down. 4 goes into 25 times. And as you can see, I end up with a remainder of 0. So my answer is going to be 0.75 with a bar. No repeating. It's a terminating decimal. Turn the page. Make sure you have these notes in front of you. Now, there's other ways of turning fractions into decimals. For example, if you have things that can go into 100, it makes it a lot easier. So if you look here, 74 over 100, that basically says that there's a 74 in the hundredth spot. So just to review place values, this spot is the tenths, and this spot is the hundredths. So if I wanted to write 74 in the hundredth spot, I would just slide that in, and there you go. My answer is 0.74, and it's a terminating decimal. You could also take in and out and do the whole division thing, but those are pretty big numbers, so if you can avoid it, do it. All right, so number 2, again, you can use the in and out function, or since 20 actually goes into 100, I can set it equal to 100. Okay, so now we're thinking 20 times what equals to 100? I know that you can multiply it by 5. So 7 times 5 will give me 35 over 100. Now I'm almost done. It's still a fraction. This basically says that there's a 35 in the hundredth spot. So I know that this is tenths, this is hundredths. I slide in the 35, and my answer is 0.35, terminating decimal. All right, our next one is a little different. It's a mixed number. So what I want you to think about is that 5 3/4 is like 5 plus 3 over 4, okay? So the 5, I'm just going to ignore that for now. I'm just going to deal with the 3 over 4 as a fraction. So 3 over 4, 4 can go into 100. Anything that can go into 100, I can use this method. So I know that 4 times 25 equals to 100. And so if I multiply 25 up here, I'm going to get 75. So I know 75 over 100 is 0.75. Now I don't want to forget about this 5 right over here. So I'm going to make sure that in my final answer I have 5.75. All right, so for our next one, 3 over 8, I know that 8 can't go into 100 evenly, so I don't want to set it equal to 100. I'm just going to go ahead and do the in and out, the traditional way, and that basically works for every problem, including the ones that go into 100. So we're going to have the 3 inside, the 8 on the outside, a decimal here, and a decimal here. The 8 goes into 3, let's see, 4 times. No, probably 3 times. That looks right. Okay, so we're going to get a 6 here and drop the 0 down. 8's going to go into 67 times. That's 56. And I'm still going to get, and I'm going to get a 4, and then I have a 0, I drop that down. 8 goes into 45 times, so I end up with a 0. Now if you have a remainder of 0, you should know that that is your terminating decimal. Okay, number 5, negative 1 over 40. Now 40 cannot go into 100 evenly. If I take 100 and divide it by 40, it won't give me a perfect number. So I will have to go ahead and do the in and out. So the 1 is in the inside, the 40 is on the outside, and I want to make sure it's a negative. Okay, so 40 can't go into 1, so I'm going to put a decimal and a 0. Now 40 can't go into 10 either, so I'm going to put a 0 as my placeholder, signifying that it can't go into 10, and then I'm going to add another 0. Okay, so 40 can go into 100, let's see, 2 times, and that'll give me 80. So if I subtract these, I'll get 20, take a 0, drop it down, and that'll give me to a 5. I subtract these, and that'll give me to a 0, so my answer is 0.025. It is a terminating decimal. All right, our last one, 7 over 9. I think, can 9 go into 100? It can't, so I'm going to go ahead and do the in and out. 7 in the box, 9 on the outside. I'm going to put a decimal and a decimal. Okay, so now I have to think, how many times does 9 go into 70? Let's see, that would probably be 7. That's our 63. All right, and then we're going to go ahead and subtract. Okay, so 9 goes into 70. Okay, so we have sort of a repeating thing here, because I know my next one's going to be 7 again. So this one looks like it's going to be a repeating. Writing decimals as fractions. The decimal system is based on powers of 10. You determine the denominator based on the place value of the decimal final digit. You must reduce all fractions into simplest form. So just to review, we have our place values. Tenths is here, hundredths is next, thousands it's next, etc., etc. Okay, so it says example 7, find the fraction of the fish in the aquarium that are goldfish. So that would be this one right over here. So let me pull that out for you, 0.15. Okay, so I'm going to look up, I'm going to see what place value does it end in. Now, the 5 ends in the 100 spot, so I'm going to say 15 over 100. And this literally reads 15 in the 100 spot. Now, I want to make sure that I reduce it in simplest form. If I divide it by 5, I'm going to go ahead and get 3 over 20. It can't go down any more, so that is my final answer. Go ahead and do the got it problems from H through G. We're going to go over the answers tomorrow in class.